Okay, are you ready for this? I hope that you have a nice refreshing drink next to you so that you can relax as we go through a little bit of a complicated section. In section 3.3.3, we're going to study how to build truth tables. Every truth table that we build will be related to those three basic truth tables for the negation, the disjunction, and the conjunction. So if you have those nearby so that you can keep an eye on them, that will be helpful. We're going to consider compound statements with more than one connective. How do I determine if a compound statement with a combination of connectives is true? Well, we build a truth table for it. We consider every single possible case of truth values for the simple statements, and using the rules of the connectives, we determine the truth value of the more complicated compound statements. Now, to build a truth table, there's a couple of rules that you'll need to know. The rule for rows. Remember, rows are horizontal. For a compound statement composed of n simple statements, the truth table will need 2 to the nth power rows. So for example, if we look at example 4, it has two simple statements, P and Q. I'm just counting the letters here. So we're going to need 2 to the second power rows. 2 to the second power is 2 times 2, or 4. So we need 4 rows. And you can see the truth table has already been set up for us. Now, the rules for columns is a little bit different. A truth table will need 1 column for each simple statement and 1 for each connective. So if I look at this example, we've already discussed we have 2 simple statements, P and Q. Now, let's count the connectives. We have 1, 2, 3. So this truth table is going to need 3 plus 2, or 5 columns. We have 3 connectives, we have 2 simple statements, so we need 5 columns. And again, the truth table has already been set up for us. Anytime we build a truth table for a complicated compound statement, we're going to begin by listing every possible truth value combination of this simple statement. And we do this the same way every time. So in columns 1 and 2 of our truth table, we have our 2 simple statements, P and Q. We're trying to figure out the truth value of this more complicated compound statement. We don't know in particular what P and Q represent, but we could read this statement, not P and not Q. So we're going to set this up again the same way every time. So we're going to consider 2 T's and 2 F's for the first column, and then we're going to alternate true and false for the second column. Again, that gives us every possible combination of truth values for the simple statements P and Q. Now, we want to build our way up to this compound statement. That compound statement, the entire compound statement, is going to be our last column. In order to judge the truth value of this conjunction, we need to know what's the truth value of the statement on the left and what's the truth value of the statement on the right. So again, I'm looking at the conjunction. Remember, that's an and an and statement is going to be true if both components are true, right? So I need to know what's the truth value of the statement on the left. Well, we know the truth value of P, but we don't know the truth value of not P. So that's the next thing I'm going to add to my truth table. Once I have that established, then I also need the truth value of the statement on the right. We've got statement Q listed on our truth table, but we need to find the truth value of not Q. In this way, we can build our way up to that compound statement. Now, each column is going to be governed by the rule for the particular connective that it has. Okay, so we're going to fill out truth values for this column. This column is statement not P. Well, we're dealing with a negation. What's the rule for a negation? A negation always has the opposite truth value of the original statement. So in order to judge the truth value of not P, I need to know what's the truth value of P. And the good news is I've already got it listed over here, right? So on row 1, if P is true, then not P is going to be false. Now, I'm not looking at this column or anything else. I'm only looking at this column to make my decision for this column, right? Let's look at the next row. If P is true, then not P is going to be false because the negation always has the opposite truth value. In this row, P is false, therefore not P would be true. And finally, if P is false, not P would be true as well. So that's going to be useful as we build up to our compound statement. Let's go to the next column. The next column we're trying to determine truth values for is headed by the statement not Q. Well, not Q is going to have the opposite truth value of the original statement Q. So I'm only going to be looking at this column as I make my decisions for this column. If Q is true, then not Q is going to be false. If Q is false, then not Q is going to be true. Remember, I'm just taking the opposite truth value of the original statement to get the truth value of the negation. You're going to love that negation. It's the easiest one to determine every single time. Okay, now we are ready to judge the truth value of our entire compound statement. We're now looking at the rule for our conjunction. Remember, a conjunction is true when both components are true. So I'm going to figure out what's the truth value of the component on the left by looking at this column. And then I'm going to figure out what's the truth value for the component on the right, which we've already figured out in this column. Okay, so looking at row 1, not P is false, not Q is false. Well, that means that our conjunction is false. Remember, I'm looking for the combination of two truths to get a true for the conjunction. Let's go to the next row. Not P is false, not Q is true. Remember, the conjunction is true only if both components are true. So this conjunction is false. Next row, not P is true, not Q is false. Therefore, the conjunction is false, because remember, I have to have the case of two truths in order to get a true for conjunction. Finally, not P is true, not Q is true, therefore our conjunction is true. So we're only ever going to be comparing two columns at a time, and each column will be governed by the rule based on the connective that it displays. Now this is going to take some practice, so hang in there. Don't give up. Let's look at an example with actual words to sort of clarify this information. Consider this statement. You're blushing or sunburned, and you're not sunburned. Under what conditions is the statement true? So we're looking at a compound statement. You're blushing or sunburned, and you are not sunburned. So I've got some simple statements connected with the words or, and not. And we're trying to figure out under what conditions is that statement true. Well, we're going to break it down into its simple components. Let's begin by identifying the simple statements. One simple statement is you are blushing or you're blushing. Another simple statement here, you're sunburned, right? You are sunburned. And the last simple statement here, disregarding any connective, I'm not going to include or, and, or not in the definition of my simple statements. We have another repetition of the statement Q, you're sunburned. Okay? So when I define simple statements, they never ever contain connectives. Now, what we want to do is take our compound statement that we have up here and express it in symbolic form. So let's give it a try. We have you're blushing. That is statement P. So I'm going to start with statement P. Then we have our connective or. The symbol for or looks like a little V. Sunburned, which completes this idea, you are sunburned. That is the statement Q. You're blushing or sunburned. Now we have a comma here which kind of groups that statement all together. So I'm going to group this statement in a set of parentheses. Our next word we have is the connective and. Then we have the statement again, you're sunburned, but it has been negated. So this is going to be not Q. So in symbolic form, the structure of our compound statement is P or Q and not Q. We can build a truth table for that compound statement, and then we can interpret when is that compound statement true or false. Now notice we only have 2 letters, 2 simple statements for this compound statement. So we're going to need 2 to the 2nd power or 4 rows, and that's already set up for us. And in addition to our 2 simple statements, we have 1, 2, 3 more connectives. So we're going to need 2 simple statements plus 3 connectives, 5, not rows, columns. 5 columns, and again, the truth table has been set up for us. We will begin by assigning every possible combination of truth values for our simple statements, P and Q. And then we're going to build our columns. Now remember, in the last column, we're always going to end up with our entire compound statement. That's what I'm working my way up to. Now, let's look at the structure of this compound statement. This compound statement is essentially a conjunction. We've got an and right here in the middle. In order to determine if a conjunction is true, I need to know what's the truth value of this statement on the left side of that and what's the truth value of the statement on the right side of that and. We have the truth values for the simple statements, but not those connectives. So on the left side of my and statement, we've got a disjunction, P or Q. And on the right side of that and, we have a negation, not Q. So let's judge the truth values building up to our compound statement. Starting with this column, in order to determine if the statement P or Q is true, I'm going to look at the truth value for P and the truth value for Q row by row. And I'm going to keep in my mind the rule for OR. A disjunction is false only when both components are false. Or another way to think about it, a disjunction is true if at least one component is true. So looking at row 1, P is true, Q is true. That's at least one true, so my disjunction is true. Row 2, P is true, Q is false. That's at least one true, so my disjunction is true. Row 3, P is false, Q is true. That's at least one true, so my disjunction is true. And finally, both components are false. Therefore, our disjunction is false. So that's an intermediate step on the way up to our compound statement, which we're trying to examine. Next column is the negation. Well, this is the easiest one. I need to determine the truth value of the statement not Q. We know it's going to be the opposite of the truth value of statement Q. So in row 1, if Q is true, not Q is false. Row 2, if Q is false, not Q is true. Row 3, Q is true, not Q is false. And finally, row 4, Q is false, not Q is true. Now we have enough information to judge the truth value of our entire compound statement. So which rule am I going to use to judge these truth values? Well, we've already figured this guy out. He's right here in this column. That's the left side. We've already figured this one out. That's the column on the right. Those two statements are connected by and. So I'm going to use the and or the conjunction rule. A conjunction is true only when both components are true. So in row 1, I have true and false. Well, both components are not true, therefore the conjunction is false. Row 2, there's the case we're looking for. Both components are true, therefore the conjunction is true. Row 3, one is true, the other one is false, therefore the conjunction is false. And we've got one false and one true on row 4, therefore the conjunction is false. It is absolutely essential that you know the rules for each individual connective so that you apply the right rule at the right time. For example, if I'm looking at this row right here under the disjunction or the OR rule, true or false would give me true. But since we were considering the AND rule, where both components have to be true, our conclusion was false. So again, it's very important that we understand which connective each column is using and what those rules are. Now we can go back and answer the original question. The original question was, under what conditions is the statement true? What statement? The statement, you're blushing or sunburned and you're not sunburned. That statement is going to be true under these conditions. That's the only time that it's true. So we're going to go back and look at the original components. The statement is true when P is true. That is, remember P was you're blushing. You are really blushing. And Q is false. Q is false. That is, you are not sunburned. So if Q is true, then you really are sunburned. If Q is false, then you're not sunburned. So it means you are blushing for none other reason than you are blushing. Okay, let's practice some more with our truth tables. Build truth tables for each of the following compound statements. In these two examples, we're just looking at abstract cases so we can practice our rules. Also notice that each of these examples have 3 simple statements each, P, Q, and R. Therefore, we're going to need 2 to the 3rd power, that's 2 times 2 times 2, or 8 rows for each one of these truth tables, and that's already set up for us. Now, looking at our first example, P or Q and R, let's figure out the number of columns. Well, I have 1, 2, 3 simple statements. So we're going to need 3 columns, and I have 1, 2 more connectives, or 5 columns. So this is going to be an 8-row, 5-column truth table. Now, to set up a truth table with 8 rows, we're going to fill the first column half with truths, so 4 truths, and half with falses. That's 4 false. Okay? Then we're going to alternate 2 and 2 on column 2. That is 2 T's, 2 F's, 2 T's, 2 F's. And then finally, continuing this pattern in column 3, we're going to alternate true and false. So true, false, true, false. We're going to set up our truth table the same way every time. This gives us every possible combination of truth values for our individual statements P, Q, and R. Now, we know that in the last column, we're going to have our entire compound statement. So I'm going to go ahead and put that over here. And notice that is a disjunction OR. In order to determine if an OR statement is true, we're going to need to know the truth value of the statement on the left side. We're going to have that listed over here. And we need to know the truth value of that statement on the right side. Well, we know the truth values for Q and R individually, but we're going to need to know what's the truth value for that compound statement, Q and R. Okay, so here we go. Looking at judging truth values for this column, this is an AND statement. 2 statements connected by an AND. Now, notice they only involve Q and R. So I'm only going to be looking at truth values from Q and truth values from R. You can take a pencil and lay it down on top of column P, so you're not even tempted to look there. Now, let's think about the rule for AND. An AND statement, a conjunction is true when what? I hope you said both components are true. So I'm looking for 2 trues. Now, one technique you can do, hold that in your mind. I'm looking for 2 trues. I'm just going to go down and find every time I get 2 trues, right? Every other time it is false. So if you get at least one false, your conjunction is false. And that column is taken care of. Next, we're going to judge the entire compound statement. Now, to judge this compound statement, we need to consider what's the truth value of the statement on the left. Well, I can look over here at column P to judge the truth value of the statement on the left of the OR. On the right side of the OR, I have the statement Q and R. Well, we've got that right here, okay? Now, again, you can take your pencil and you can cover up these 2 columns so that you don't look at them. We're only going to be looking at column P and column Q and R. The rule that we're going to use is the rule for OR, the disjunction rule. When is a disjunction true? A disjunction is true when we get at least one true, right? So looking at row 1, we've got 2 trues. The OR statement is true. Row 2, that's at least one true, so the OR statement is true. Remember, I would judge that differently if it were a different connective, so it's really important to identify which connective we're dealing with. On row 4, we have at least one true, so the statement is true. Row 5, that's at least one true. And then here's the special case. Remember, a disjunction is false when both components are false. And that's going to be the case for these last 3 rows. So if this were attached to an English statement, now we would know under what conditions it's true and what conditions it's false in terms of its original simple statements. Okay, I hope you're getting the hang of this. Remember, it takes a little bit of practice. The key to mastering this is knowing your basic rules. What's the rule for negation? What's the rule for and what's the rule for or? Let's try this compound statement. We can read it not P or not Q or R. Notice we have 1, 2, 3 simple statements, so we're going to need 2 to the 3rd power or 8 rows, and we've already established that. But as far as columns go, we're going to need 3 simple statements plus, let's count our connectives. We have 1, 2, 3, 4 connectives, so we're going to need 7 columns total. Keep that in mind as you build your truth tables with pencil and paper on your own. So we need 7 columns. We're going to set it up the same way we did our previous 8-row truth table. That is, in column 1, the first 4 spaces get a T, and the second 4 get an F. In column 2, we're going to do 2 and 2. 2 T's, 2 F's. 2 T's, 2 F's. And then remember, in column 3, we alternate one at a time. True, false, all the way down. Now, we know in the last column, our final conclusion is going to be our entire compound statement. That's my goal. That's what I'm working up to. Now, this is basically a disjunction. 2 statements connected by an or. Both statements on either side of that or happen to be compound statements, but we can still judge it as a disjunction, an or. The statement on the left of that or is not P. I'm going to need to know its truth value. So that's going to be my next column heading, not P. The statement on the right of the or is a compound statement. In order to judge the truth value of that compound statement, which also happens to be a disjunction, I'm going to need to know what's the truth value of the statement on the left. I'm going to need to know what's the truth value of not Q. I've got Q, but I'm going to need to use that to judge not Q. Then the statement on the right of this disjunction is R. That's already listed right here, so we have that taken care of. But once I know the truth value for not Q and the R, I can judge this entire statement on the right, not Q or R. Okay? All right, let me clean this up a little bit, and we'll get started with truth values. Column 1 is going to be an easy one. to get the truth value for not P, the negation, we're only going to be looking at the truth values for P. And remember, the rule is a negation has the opposite truth value of the original. So just as column P has 4 T's and 4 F's, we're going to reverse all of that. We're going to have 4 F's and 4 T's for the negation. The next column, good news, it is also a negation. So to get the truth value for not Q, I'm just going to be looking at the truth value for Q and reversing everything. Looking at column Q, we have 2 T's and 2 F's. I'm just going to reverse that for not Q. We're going to have 2 F's and 2 T's, 2 F's and 2 T's. Next column, we are dealing with a disjunction OR statement. To determine the truth value for an OR statement, we're going to look at the statement on the left side, which is not Q, and the statement on the right side, which is R. Now, these are in reversed position, but the rule works the same. A disjunction is true when at least one side is true. So on row 1, we have at least one true. The disjunction is true. Row 2, we've got 2 falses. The disjunction is false. Now, you may be tempted to want to say 2 negatives make a positive. That might be something that enters your mind. So you really have to stay focused on what the rule for an OR is. An OR statement is false when both sides are false. Okay, it's essential to know those rules. And an OR statement is true when we get at least one side true. Row, let's see, 6 here, there's 2 falses. The disjunction is false. Row 7, at least one true is true. And row 8, at least one true is true. All right, we are almost there. The last thing we have to consider is this disjunction rule. To judge the truth value of this OR statement, I need to look at the truth value of the statement on the left of the OR. That's not P, so I'm going to look at column not P. On the right side of this OR statement, I've got the compound statement, not Q or R, so I'm going to be looking at this column. Now, I recommend take a pencil or a finger, something like that, and cover up this guy in the middle so you're not tempted to look at it, so we can make the proper judgment for our last column here. An OR statement is true if at least one side is true. So row 1, that's at least one true, we get a true. Row 2, 2 falses make a false under the OR, right? Next row, that's at least one true. Row 4, that one's true. 2 trues make a true. And then it looks like the last columns are all going to be true. Now that we have the truth table completed, we could go back and analyze a statement and determine when is a compound statement that has this structure true and when is it false. We might focus on this one because that's the only one that stands apart. That statement will always be true except when P is true, Q is true, and R is false. And then we could use that to interpret what does this mean with regards to our simple statements. Okay. Take that ice cold refreshing drink, have a sip, take a deep breath. Feel free to watch this video as many times as you need and email me if you have any questions. And again, the key to filling out these basic truth tables are some things. Know the rules for your connectives, not and and or. When are those true and false? And understand how do I determine how many rows? How do I determine how many columns? And then how do I set up the truth values for my simple statements? Remember, when you're filling out a big truth table like this, you're only maximum going to be comparing 2 columns at once and applying one rule at a time. Okay, I hope that you feel yourself growing in logic, and I'll see you in the next video.